So we're going to pick up where we left off. In this part, we're going to go ahead and finish the rest of the notes here. So this says, what if you want to convert from a polar coordinate to a rectangular, also known as a Cartesian coordinate? So that's just your typical XY coordinate points. So right here, if I was given this diagram right here, and I was instead given a number for my R and a number for my theta. So let's pretend. I'm just going to make something up. So let's say my R is 4, and my theta is, let's do 32 degrees. If that's what I had right there, and I wanted to solve for X and Y, well, let's go ahead and do that. So here's X right here. If I wanted to solve for that, I'd go, well, X right here is adjacent to my 32 degrees, and I have my hypotenuse. Adjacent and hypotenuse would be cosine, right? So you'd set that up as cosine 32 is equal to adjacent over hypotenuse, so X over 4. And then to solve for X, you'd go ahead and multiply 4 to both sides, and you'd say that X is equal to 4 times the cosine of 32, right? And then in order to solve for Y, you do the same thing, except that would be opposite and hypotenuse. So you'd say you'd say sine 32, because that's your opposite and hypotenuse, is equal to Y over 4. And then in order to solve for Y, again, just like before, you'd multiply that 4 to both sides, and you'd have Y is equal to 4 times sine 32. So in short, the equation that you would do if you were trying to convert between polar coordinates to rectangular is you're going to use one that you should already be familiar with, and that's just R cosine theta and R sine theta get you your X and your Y coordinates in rectangular form. So no matter what the R is, and no matter what the angle is, that's how you can set that up, is R times the cosine of the angle is your X coordinate, and R times the sine of the angle is your Y coordinate to get it between polar coordinates and rectangular. Okay, don't forget the R part though, because, for example, if it's just pi over 3, well, cosine of pi over 3 is 1/2, right? But we still have to multiply it by the R. You have to multiply it by whatever the radius is. So that's exactly what we're going to do right here. So if this is 2 pi over 3, 2 is the radius, pi over 3 is my angle. So I would set this up as 2 times cosine pi over 3 and 2 times the sine of pi over 3. And I'm going to do that, and then I can go ahead and simplify with the information that I know. Just like I said just a second ago, the cosine of pi over 3 is 1/2. So now I have 2 times 1/2. And then I have 2 times the sine of pi over 3. And the sine of pi over 3 is the square root of 3 over 2. So once I multiply those out, the 2's end up canceling out. And so then my final answer, my XY coordinate in rectangular form, is just 1 square root 3. And that's where I would plot that on a Cartesian coordinate plane. Likewise, right here, if I did 4 negative 3 pi over 4, well, I have 4 times the cosine of negative 3 pi over 4, and then I have 4 times the sine of negative 3 pi over 4. And so then I just go ahead and simplify that. And so the cosine of 3 pi over 4, that's equivalent to 5 pi over 4. It's in my third quadrant. So that's going to get me a negative square root 2 over 2. And then the same thing here for the sine, because both my cosine and sine are negative square root 2 over 2 in that quadrant. And then when I distribute that, the 4 and the 2 ends up reducing and just giving me 2. So then I have negative 2 square root 2 times negative 2 square root 2. I shouldn't say times, but that's my X, and this is my Y. Okay? Now, if I wanted to convert between Cartesian coordinate and polar coordinates. So same kind of concept right here. That means instead I know my X and my Y, I need to find my R and my theta. So let's use the example right here that I have for A, and let me go ahead and label that up here. A is a Cartesian coordinate point, so my rectangular coordinate, and I need to make that be polar. So I need to turn that into an R theta. So the 2 represents my X and the 3 represents my Y. So if this is what I had, I just have a triangle right now where I have a 2 and a 3 right here, and I need to solve for the angle, and I need to solve for my radius or my hypotenuse. So given this information, if this is what I have right here, I can set this up using my Pythagorean theorem to get my r, because it would just be 2 squared plus 3 squared equals r squared. And then I would use inverse trig in order to solve for my angle. In this case, I'm going to want to use inverse tangent because that's going to get me using the sides that I already have. So let's go ahead and do that. So if I was to do this right here, I would go ahead and do my Pythagorean theorem, where I would say that I have 2 squared plus 3 squared equals r squared. So that's going to get me 4 plus 9 is equal to r squared. So I'm going to have r squared is equal to 13, right? So if I solve for that, I'm going to square root both sides, and so I get r is equal to plus or minus the square root of 13. But our r is going to be positive here. So it's just the square root of 13, okay? So that's what I get, square root 13 right here. In this case, yes, if I could use something besides inverse tangent to solve for my angle because I have all 3 sides, but I don't want to do that. Simply because if I somehow or another solved incorrectly, which a common mistake here in this particular example would be somebody saying 3 squared is 6, just kind of in a rush and just rushing and doing something instead of going 3 squared is 9, somebody typically will go 3 times 2. It's just a simple, human error. And if you did that, then that means that not only is your radius wrong, but if you use that radius to find your missing angle, it means that that angle is also going to be wrong. So you always want to use the information that you're given, not the information that you solve for. So in this particular case, what I would do now is I would do inverse tangent, and I would do opposite over adjacent. So opposite would be 3, 2 would be my adjacent. So I'd set this up as tangent inverse I'm sorry, I already forgot the numbers, 3 and 2. 3 over 2 is going to get me my theta, okay? And, what I would do is I'd put that in the calculator and get some value, and that would get me the actual angle measure in radians. However, this is not an exact value. It's not something that's going to be on our unit circle, so we're just going to kind of leave it like this for right now because we don't know if this is a calculator question or a non-calculator question. So we're going to get used to kind of looking at them in both ways. So going forward, the equations that you would use in order to go from a Cartesian coordinate to polar, in order to get your r, it's equal to the square root of x squared plus y squared. And to get your theta, that's going to get you tangent inverse of y over x. Those are the equations that you're going to want to use to convert from a Cartesian coordinate or a rectangular coordinate into a polar coordinate. Okay, so right here, we're going to go ahead and write this as our final answer. In a polar coordinate would be square root 13. And then I'm going to leave this, oddly enough, as tangent inverse 3 over 2. I know when we originally did this in class, I had you guys put them in the calculators, but we had a further discussion the other day about we're not going to do that all the time. We're going to see them kind of in both ways because really we don't know what to expect on the AP exam. So this could be a potential way to see it. That's just without a calculator, right? Now, if you had a calculator, obviously you'd get an exact answer. Now let's do B. B right here. If I do this, I have r is equal to the square root of -1 squared plus 5 squared. So that's going to get me my r is equal to the square root of 26. That does not reduce any further, so that's what I'm going to leave it as. And then I'm going to go ahead and do my tangent inverse. This one's a little bit different though. And the reason this is different is because of where it's located, okay? So let's look. If I was to take this and plot B here, it's at -1, 5. 1, 2, 3, 4, 5, right? It's going to be up here. That's in my second quadrant. If I do inverse tangent, where does that get me my answer? it gets me an answer between negative pi over 2 and pi over 2. So it gets me an answer over here or over here. And since this is a negative tangent, my answer is going to be here. So instead of just leaving it as the value that I would get, I have to think about this. I have to go, okay, so this is right here, but I need to get here. So I'm going to have this inverse tangent plus pi, because I'm going to have to go from something over here to here. Okay? So that's how I'm going to actually get that value here. So I'm going to leave it like this as the square root 26. So my final answer would be square root 26. And then I would have tangent inverse of 5 over negative 1 plus pi. That would be my exact answer without using a calculator. Okay? And then 0, 4. Much like this one, let's think about where we're located. Okay, so if I'm at 0, 4, that means that I'm not going side to side on my x-axis. I'm just going 4 up. Well, if that's in radians, where's that at? That's at pi over 2, isn't it? Okay. If I was, for example, to take my calculator and do tangent inverse 4 over 0, if I did that, well, that's going to go, well, I can't divide by 0. That's undefined. So anytime I'm at my pi over 2 or my 3 pi over 2 or any of their coterminals, it's undefined for tangent. And so if I do have a calculator, I can always know that that's where it's at. If I don't have a calculator and I just plot my point and I can see I'm either going straight up or straight down, then that's how you know that it's either pi over 2 or 3 pi over 2. Okay. My r in this case, it's really straightforward. You know, you're just going to do 0 squared plus 4 squared. Well, that's going to get me the square root of 16, which is just 4. So your final answer in this one would be 4 pi over 2. I was able to do that without doing any sort of calculating or anything like that. I just knew it was pi over 2 because of plotting it right here and seeing that it's straight up. Okay? Hopefully that's going to make some sense of these. I know B and C are a little bit difficult if you don't really plot things and think about it, and I anticipate that this right here is going to be a little bit of a challenge. So we definitely need to practice that.